more practice solving linear equations with fractions and decimals. We've been solving linear equations, but none of them have included fractions or decimals. So let's talk about what we need to do when our equations contain those. The procedure to solve any linear equation is to first distribute to get rid of the parentheses. But then, if we have fractions, we can get rid of the fractions by using the LCD. Remember, that stands for the least common denominator. If we have decimals, we can get rid of the decimals by moving the decimal points to the right. Then we follow the same rules that we would for any linear equation by collecting like terms on the same side of the equation, get the variables on the same side of the equation, move the numbers away from the variables by performing opposite operations, and then we can always check our solution by substituting into the original equation. So to solve an equation that contains a lot of decimals, then we can get rid of the decimals by moving every decimal point to the right in every term, depending on the number or the maximum number of decimals that is in the equation. The first thing, though, we have to do is get rid of the parentheses. So in this first example, let's get rid of these parentheses by distributing this 1/10 into the parentheses. So I have 0.25x or 25 hundredths plus 0.1x minus 0.3 equals 1.1. Now that the parentheses are gone, we can get rid of the decimals. Well, when we look at the number of decimals in each term, if I look in this first term, there are 2 decimal places. There's 1 here, 1 here, and 1 here. So the maximum number of decimal places in any term is 2. This one has 2 decimal places. So to get rid of the decimals, we need to move the decimal to the right 2 places in every term. Whatever the most is, that's what we're going to do in every term. So if I move the decimal 2 places to the right in this term, that changes my number to 25x. If I move it 2 places to the right in this term, there's not another number, so I would just add a 0, and that would give me 10x. Minus, again, if I move this 2 places, I would get 30, equals 2 places here would give me 110. And now I have a linear equation with no decimals, and I would solve it just like I would any other linear equation. I want to combine my like terms. 25x plus 10x would be 35x. Then I need to move the stuff away from the x, so I'm going to add 30. That gives me 35x equals 140. I'm going to write it right here. And then I divide both sides by 35. And 35 will go into 144 times. And that's how, and we don't have to put any decimals back in it because of the fact that we moved all of the decimals the same number of places. Then this is the answer we would have gotten even if we wouldn't have moved the decimals. But it's a lot easier to get rid of the decimals. All right, let's try it in another linear equation. Here we have another set of parentheses, and we've got to get rid of those first, so I'm going to distribute, and I have 0.112x minus 0.72 plus 0.06x equals 0.08x minus 0.7. Okay, so this has 2 decimal places, this has 2 decimal places, 2 decimal places, 2 decimal places, and 1 decimal place. So the most number of decimal places in any term is 2. So we're going to move the decimal 2 places to the right in every term. And that would give me 12x minus 72 plus 6x equals 8x minus 70. Now let's combine our like terms. 12x plus 6x, that's 18x minus 72 equals 8x minus 70. All right, I'm going to get my x's on the same side of the equation. That gives me 10x minus 72 equals negative 70. And then if I add 72, let's move it over here. That gives me 10x equals 2. Divide by 10. And just because I started out my equation in decimal form, I think that my answer should probably be written in decimal form. Instead of 2/10 or reducing it to 1/5, to write this in decimal form, this is 2/10. So I would write it like this, as 2/10. All right, now to deal with an equation that has fractions, we can get rid of the fractions by multiplying every term in the equation by the least common denominator, or the LCD. So if we look at number 3, what is the least common denominator in number 3? Well, if we look at all of the denominators, first choose the biggest denominator and see if the other two denominators will divide into that number. Well, 2 can divide into 4, but 3 can't. So then if I multiply 4 by 2, I get 8. Again, 2 can divide into 8, but 3 can't. So now I'm going to multiply 4 times 3, and I would get 12. Okay, 2 can divide into 12, and so can 3. And of course, we know 4 can. So 12 would be my least common denominator. Once I determine what my least common denominator is, I'm going to multiply every term by the least common denominator. If I multiply by 12, then I'm multiplying just the numerators. That would be like 12 over 1 times 12. Times the terms in the equation. Okay, so this would be 36 over 4x minus 12 times 1 is 12 over 2 equals 12 times 1 again is 12 over 3. Now, when I reduce my fractions, 36 divided by 4 is 9. 12 divided by 2 is 6. And 12 divided by 3 is 4. Now my fractions are gone. I'm going to solve the equation by adding 6. That leaves me with 9x equals 10. Divide by 9, and this time, since I started with a fraction, it's okay for me to have my answer as a fraction. Of course, I would need to reduce it if I could, but 10 over 9 won't reduce, so that's my answer. In number 4, my denominators are 2 and 4. So what is my least common denominator? It would be 4. And I need to multiply every term by the least common denominator, even if it's not a fraction. So if you'll notice, I have 1, 2, 3, 4 terms. All 4 terms need to be multiplied by the least common denominator. So if I multiply that out, I get 20 over 2x minus 4 equals 4x plus, that would be 4 over 4. Once again, when I reduce my fractions, that is a funny looking 4. Let me fix that. When I reduce my fractions, I get 10x minus 4 equals 4x plus, and that would be a 1. And so again, all my fractions are gone. I'm going to get my x's to one side and my stuff without x's to the other side. So this gives me 6x minus 4 equals 1. To move my 4 to the other side, I'm going to add 4. And that gives me 6x equals 5. and then I divide by 6, and my answer is 5/6. All right, so let's look at another example. These are linear equations that have fractions, but if you'll notice, this is a single fraction equals a single fraction. And when we have one fraction equals one fraction, we call that a proportion. And to solve a proportion, all we have to do is cross multiply. So when we cross multiply, we're just multiplying the numerator of one side with the denominator of the other side, and vice versa. So if I do that, x times 3 is 3x. 6 times 2 is 12. And then to solve this, we just want to get x by itself, and we would do that by dividing, and that would give me x equals 4. And that's it. Now for number 6, you may say that's not a fraction equals a fraction, but if I do this, it is. So now that I have a fraction, one fraction equals one fraction, I can cross multiply. 3 times x plus 3 times 1 would just be the 3 times x plus 3, because if I multiply it times 1, it doesn't change. Then 5 times the 2x plus 6. This 2x plus 6 is stuck together because it has a plus sign in between. So that's 5 times 2x plus 6. Now I need to get rid of the parentheses by distributing. So that's 3x plus 9 equals 10x plus 30. Okay, and once again, my fractions are gone. Let me get my x's to one side and my stuff without x's to the other side. All right, I'm going to subtract 10x. That gives me a negative 7x plus 9 equals 30. Subtract 9, and I get negative 7x equals 21. Divide by 7, negative 7, and I get that x equals a negative 3. And that's it.